Hello students. Welcome to your school YouTube channel. Today's topic is, why do objects float or sink in water? So without wasting time, let's quickly start the video and learn. Chapter 1. Floating and sinking, the everyday mystery. Imagine this. You drop a wooden stick in a bucket of water, it floats. You drop a metal key, it sinks. But wait, a heavy ship made of metal can float on the ocean. Strange, right? What's really going on here? To answer this, we need to understand a few things from physics: density, buoyant force, and Archimedes' Principle. Let's break it down step by step. Chapter 2. What is buoyancy? Buoyancy is the force that pushes objects upward when they are in a fluid like water or air. This force acts against gravity. It's the reason why you feel lighter in water. It's the reason boats, ice cubes, and even you can float. Let's try a simple example. Take a plastic bottle and fill it with air, it floats. Now fill it with water and seal it, it might sink or float halfway. Why? The upward force, buoyant force, is now equal to or less than the downward force, weight. Chapter 3. Archimedes' Principle, the floating law. The great Greek scientist Archimedes gave us the golden rule of floating. Any object fully or partially submerged in a fluid is pushed up by a force equal to the weight of the fluid it displaces. Let's understand that. If you put something in water, it pushes water away. The amount of water pushed away has weight. That weight becomes the buoyant force. So, if buoyant force, object's weight, it floats. Buoyant force, object's weight, it sinks. Buoyant force, object's weight, it stays suspended in water. Chapter 4. What is density? This is super important to understand floating and sinking. Let's say, a small object can be very heavy, high density, or very light, low density. Water has a density of about 1 g per cubic centimeter. If an object's density is less than 1, it floats. If more than 1, it sinks. Wood 0.6 g per cubic centimeter floats. Steel 7.8 g per cubic centimeter sinks unless shaped like a ship. So it's not just about weight. It's about how tightly packed the mass is inside. Chapter 5. Why do ships float? Let's bust the big myth. Ships are made of metal, and metal is heavy. So how does a cruise ship weighing thousands of tons float? Here's the secret. Ships are hollow inside, filled with air and large spaces. This makes the average density of the ship less than water. It displaces a large amount of water, and the buoyant force becomes very strong. So, a ship floats not because it's light, but because it's designed to displace a huge volume of water. Chapter 6. Why do ice cubes float? Ice is water, so why does frozen water float on liquid water? When water freezes, it forms a special crystal structure with empty space inside. So ice is less dense than water, about 0.9 g per cubic centimeter. That's why ice floats, and that's also why only part of it is above water. Fun fact. That's how we get icebergs, floating mountains of frozen fresh water in salty oceans. Chapter 7. Real-life examples that make you think. 1. Oil in water. Oil floats on water. Why? Oil is less dense. That's why oil spills float and form layers. 2. Pebbles and rocks. Rocks are denser than water, they sink. Even a small rock can be heavier than a large plastic object. 3. Football in a pool. Air inside the ball makes its density very low, it floats and bounces back up. 4. Soap in water. A dry soap bar sinks, but if it has air bubbles or is used and becomes lighter, it may float. Chapter 8. Salt water versus fresh water. Ever swam in the ocean and noticed that floating is easier? Here's why. Salt water is denser than fresh water, so it gives more buoyant force. That's why it's easier to float in oceans or the Dead Sea. Ships float a bit higher in oceans than in rivers. Chapter 9. Smart thinking. It's not just about weight. Let's compare two objects. A tiny gold coin dense and a huge beach ball light. Even though the coin is small, it sinks. Even though the ball is huge, it floats. So floating doesn't depend on size alone, shape alone, weight alone. It depends on energy, density, displacement, buoyant force. Chapter 10. Why some objects first float, then sink. Have you ever seen something float for a second, then sink slowly? That happens when The object initially traps air or pushes a lot of water. As air escapes, the object becomes heavier and starts to sink. Example: a sponge filled with air may float. Once soaked, it may sink. Chapter 11. Why do we float in water? Our bodies are about 60% water and also contain air in lungs. So, alcohol. When you take a deep breath, you float better. If you exhale completely, you may sink slowly. That's why some people float more easily than others depending on body fat, muscle, and lung capacity. Chapter 12. How do submarines control floating? Submarines use ballast tanks filled with air or water. To float, they fill tanks with air, lowers density. To sink, they fill tanks with water, increases density. They control buoyancy artificially, which is called neutral buoyancy, where the sub neither sinks nor rises. Chapter 13. Summary of key concepts. Let's put it all together like a smart sheet. Concept, meaning, effect. Buoyant force, upward force by fluid opposes weight. Archimedes Principle, float force, weight, a displaced fluid, more fluid displaced, more lift. Density, mass per unit volume, load, density floats. Displacement, water pushed away by object, more displacement, more buoyant force. Floating condition, buoy and force, weight, object stays up. Chapter 14. How to test it yourself, fun experiments. Here are a few easy experiments. 1. Sink or float game. Take different objects: coin, rubber, paper, plastic spoon, metal spoon, fruit. Predict: will it float or sink? Test and observe. 2. Salt water versus freshwater. Filter glasses. One with fresh water, one with salty water. Drop an egg. In fresh water, it sinks. In salt water, it floats. Why? Salt increases density. Chapter 15. Real-world applications. Boats and ships designed with hollow hulls to float. Life jackets made of foam that's less dense than water. Hot air balloons, same idea, but in air instead of water. Submarines use science to float, sink, and hover. Final chapter. So why do objects float or sink? To answer your original question in one smart sentence: objects float or sink in water depending on how their density compares to water and how much buoyant force the water gives them by displacement. It's not about weight alone, it's about how mass and volume combine to affect density, and how that density interacts with the fluid around the object. So next time you see something floating or sinking, think like Archimedes. Bonus tip, smart trick for exams. If an object displaces more water than its own weight, it floats. If it displaces less water than its own weight, it sinks. Hello students, let's get to know me. The type of videos I make here are very important for your school, college, and higher studies. I do a lot of research and find answers to your questions. But for physical problems, I make voiceovers through AI. I upload 1 videos here every day. If you have any problem, please comment and let me know what your problem is, and I will try to answer it as soon as possible. Thank you on behalf of your school YouTube channel.